Imagine your API suddenly receives a million requests in just a few minutes. Would it survive? That's exactly the problem rate limiting solves. In this video, we'll learn why APIs need rate limiting, explore the most common algorithms used in production, and see how companies implement it at scale. Rate limiting controls how many requests a client can make within a specific period of time. For example, an API might allow 100 requests per minute per user. Once that limit is reached, additional requests receive an HTTP 429 response. Think of it as a gatekeeper that protects your backend from excessive traffic. Rate limiting isn't just about blocking requests. It prevents abuse from bots and scrapers, ensures one user can't consume all available resources, maintains consistent performance during traffic spikes, and protects backend services from overload. In short, it keeps your APIs fair, fast, and reliable. Every API request consumes resources: CPU, memory, bandwidth, databases, and sometimes even paid third party services. Without limits, traffic spikes can quickly become expensive. Rate limiting helps turn unpredictable infrastructure costs into something much more manageable. One overloaded service rarely fails alone. As response times increase, clients start retrying requests. Those retries create even more traffic, putting additional pressure on downstream services like databases. This chain reaction is called a cascading failure. A rate limiter stops the problem at edge before it spreads through the system. Rate limiting is also an important security layer. It slows down brute force login attempts, reduces large scale scraping, and limits abusive traffic before it reaches your application. Repeated limit violations can also act as early warning signals for suspicious activity. Token bucket is one of the most widely used rate limiting algorithms. Tokens are added to a bucket at a fixed rate, and every request consumes one token. If tokens are available, the request is allowed. If the bucket is empty, it's rejected. Because unused tokens accumulate, the algorithm can handle short bursts of traffic while still enforcing an average request rate. Leaky Bucket takes a different approach. Incoming requests are placed into a queue and released at a constant rate. Even if traffic arrives in bursts, downstream services see a smooth, predictable flow. It's ideal when stable throughput matters more than burst handling. Fixed window counts requests within a fixed interval, like 1 minute. It's simple and efficient, but clients can exploit window boundaries to send large bursts of traffic. Sliding window continuously evaluates the most recent time period, making enforcement much more accurate at the cost of a little extra complexity. In production, requests are handled by many servers. If each server tracked limits independently, users would bypass restrictions simply by hitting another server. That's why distributed rate limiters use a shared store like Redis. Every server updates the same counter using atomic operations, ensuring limits are enforced consistently across the entire system. In the system design interviews, don't stop after explaining the algorithm. Talk about the distributed counters, Redis, atomic increments, TTLS, and HTTP 429 responses with retry after headers. Most importantly, explain why you choose a particular algorithm and the trade offs involved. That's what interviews are really looking for. Here is a common interview question: which rate limiting algorithm allows short bursts while still enforcing an average request rate? Token bucket. Because unused tokens accumulate over time, The system can absorb temporary spikes without exceeding the long-term rate limit. Let's put everything together. Requests first arrive at a load balancer and are distributed across multiple API gateways. Before processing a request, each gateway checks a shared Redis counter. If the client is within its limit, the request continues to the API. Otherwise, the gateway immediately returns an HTTP 429 response. This design keeps rate limiting fast, consistent, and scalable across thousands of servers. Rate limiting is much more than blocking requests. It protects infrastructure, improves fairness, reduces costs, and helps keep systems available under heavy load. If you found this deep dive helpful, consider subscribing for more system design videos. Thanks for watching, and I'll see you in the next one.